Hi, welcome to the ComSci 137 lecture. Sunny here. For this module, we'll be discussing IP support protocols. Let's start. IPv4 has deficiencies. It has no error reporting or error correcting mechanism. What happens if something goes wrong? What happens if a router must discard a datagram because it cannot find a route to the final destination, or because the time to leave field has a zero value? The IP protocol also lacks a mechanism for host and management queries. A host sometimes needs to determine if a router or another host is alive. The Internet Control Message Protocol version 4 has been designed to compensate for the above two deficiencies. It is a companion to the IP protocol. ICMP itself is a network layer protocol. However, its messages are not passed directly to the data link layer as would be expected. Instead, the messages are first encapsulated inside IP datagrams before going to the lower layer. When an IP datagram encapsulates an ICMP message, the value of the protocol field in the IP datagram is set to 1 to indicate that the IP payload is an ICMP message. ICMP messages are divided into two broad categories: error reporting messages and query messages. The error reporting messages report problems that a router or a host may encounter when it processes an IP packet. The query messages, which occur in pairs, help a host or a network manager get specific information from a router or another host. For example, nodes can discover their neighbors. Also, hosts can discover and learn about routers on their network, and routers can help a node redirect its messages. An ICMP message has an 8-byte header and a variable size data section. Although the general format of the header is different from each message type, the first 4 bytes are common to all. The first field, the ICMP type, defines the type of the message. The code field specifies the reason for the particular message type. The last common field is the checksum field. The rest of the header is specific for each message type. Here are some of the debugging tools that use ICMP packets. We can use the ping program to find if a host is alive and responding. We use ping here to see how it uses ICMP packets. The source host sends ICMP echo request messages. The destination, if alive, responds with ICMP echo reply messages. The ping program sets the identifier field in the echo request and echo reply message and starts the sequence number from 0. The number is incremented by 1 each time a new message is sent. Note that ping can calculate the round trip time. It inserts the sending time in the data section of the message. When the packet arrives, it subtracts the arrival time from the departure time to get the round trip time. The traceroute program in Unix or tracert in Windows can be used to trace the path of a packet from a source to the destination. It can find the IP addresses of all the routers that are visited along the path. The program is usually set to check the maximum of 30 hops to be visited. The number of hops in the internet is normally less than this. Physical addresses and logical addresses are two different identifiers and are needed both. A physical network, such as Ethernet, can have two different protocols at the network layer, such as IP and IPX, at the same time. A packet at a network layer, such as IP, may pass through different physical networks, such as Ethernet and LocalTalk. The Address Resolution Protocol is one of the auxiliary protocols defined in the network layer. ARP accepts an IP address from the IP protocol, maps the address to the corresponding link layer address, and passes it to the data link layer. Here shows the format of an ARP packet. The hardware type field defines the type of the link layer protocol. Ethernet is given the type 1. The protocol type field defines the network layer protocol. IPv4 protocol is 0800 in hexadecimal. The source hardware and source protocol addresses are variable length fields defining the link layer and network layer addresses of the sender. The destination hardware address and destination protocol address fields define the receiver link layer and network layer addresses. An ARP packet is encapsulated directly into a data link frame. The frame needs to have a field to show that the payload belongs to the ARP and not to the network layer datagram. Here is an example of an ARP request and an ARP reply. You may notice that the destination hardware address is all zeros in the ARP request. The ARP reply will now include the receiver's hardware address at the source hardware address. There are occasions in which the host knows its physical address but it needs to know its logical address. One is when a diskless station is first booted. Another is if the organization does not have enough IP address to assign each station. There are three protocols that are used in this situation: the reverse ARP, bootp, and DHCP. The Reverse Address Resolution Protocol is a TCP/IP protocol that allows a host to find its internet address given its physical address. A reverse ARP request is created and broadcast on the local network. Another machine on the local network that knows all the IP address will respond to the reverse ARP reply. The problem with this is that broadcasting is done at the data link layer. It does not pass the boundaries of a network. The Bootstrap protocol, or bootp, is an application layer protocol used to automatically assign an IP address to network devices from a configuration server. Dynamic Host Configuration Protocol is an application layer program that provides static and dynamic addresses allocation that can be manual or automatic. In static address allocation, it acts as what bootp does. The DHCP server has a database that statically binds physical addresses to IP addresses. In dynamic address allocation, DHCP has a second database with pool of available IP addresses. Here is the general format of a DHCP message. Most of the fields are explained in the figure, but we need to discuss the option field. The 64-byte option field has a dual purpose. It can carry either additional information or some specific vendor information. The server uses a number called the magic cookie in the format of an IP address with the value 99.130.83.99. When the client finishes reading the message, it looks for this magic cookie. If present, the next 60 bytes are options. An option is composed of three fields: a 1-byte tag field, a 1-byte length field, and a variable length value field. There are several tag fields that are mostly used by vendors. If the tag field is 53, the value field defines one of the 8 messages types shown in the lower right. Here is a simple scenario of DHCP messaging. First, the joining host creates a DHCP discover message in which only the transaction ID field is set to a random number. No other field can be set because the host has no knowledge with which to do so. This message is encapsulated in a UDP user datagram with the source port set to 68 and the destination port set to 67. Next, the DHCP server or servers responds with a DHCP offer message in which the address field defines the offered IP address for the joining host and the server address field includes the IP address of the server. The message also includes the least time for which the host can keep the IP address. This message is encapsulated in a user datagram with the same port numbers but in the reverse order. Next, the joining host receives one or more offers and selects the best of them. The joining host then sends a DHCP request message to the server that has given the best offer. The fields with known value are set. The message is encapsulated in a user datagram with port numbers as the first message. The user datagram is encapsulated in an IP datagram with the source address set to the new client address, but the destination address is still set to the broadcast address to let the other servers know that their offers were not accepted. Finally, the selected server responds with a DHCP ACK message to the client if the offered IP address is valid. If the server cannot keep its offer, the server sends a DHCP NACK message and the client needs to repeat the process. This message is also broadcast to let other servers know that the request is accepted or rejected. This ends Module 20. Thank you.